Hello. In this video we'll learn about position vectors and unit vectors. And they're very simple concepts, but also they're very fundamental when we deal with force vectors in 3D settings. It's sometimes confusing because it has a lot of calculations and dealing with coordinates in 3D. But if you follow a systematic process, it will be very simple, and over time you'll just be like a very kind of background, typical mental process you do in 3D equilibrium problems. So the first thing we'll cover is position or point position vectors. So a position vector for a point. So for this example here, we have point A. And to define its position, we have this vector that links between the origin of the coordinate system and the point. So it's basically kind of putting the coordinates of A, x, a, y, a, z, a, into a vector format. It's that simple. Now for that vector, RA, with the head kind of arrow, I can calculate the magnitude, and we know from calculus the magnitude of a vector is the square root of the orthogonal components, x, y, and z components of the vector. Or basically here, as we're dealing with a position vector of a point, it's basically the coordinates of the point. So the magnitude of this vector are a magnitude, and also I can write it as length OA. It says the length between the origin and the point. So I can write it as the magnitude or absolute of RA vector, or I can actually also write it as OA, just the length of OA. And then the other thing we will cover is unit vector. So the unit vector is a vector of unit length to define the direction of a vector from a point to a point. So in this case here, it's lambda a, and it's a vector in the same direction of RA, but it has a length of 1. So it depends on the units you're using. If it's international units, though, it will have a 1 meter length. So lambda a, or the unit vector of a, is equal to RA as a vector divided by the magnitude of RA. So it's equal to the position vector over the magnitude of that vector. So just to simplify that, then you just divide every component over the magnitude of the vector, and you will end up with the unit vector. So that's the position vector for a unit, for a point, and also building on that, learning about the unit vector. Another thing, so we need to generalize from that, is the position vector between any points. It doesn't have to be from the origin to a point. Now we're in equilibrium problems. You will see forces going in all directions from all points. So we want to learn something we can apply on a general setting. So position vector between 2 points is the general setting. It's not from the origin to a point. So we have here 2 points A and B, and each one we know the coordinates for it. I can get the position vector for each point, which is basically a vector representation of its coordinates. And the question is, what will be the position vector between A and B? The direction here matters a lot. So RAB is different than RBA. So RAB is the position vector from A to B. So how to calculate that? It's using the basic principle of summation of vectors. So if you look at this triangle that's made of the two vectors and the red vectors and the purple one, we want the purple one. We're kind of given the red ones, RA and RB. So from just looking at the triangle, RA, if you move from the origin to A, and then move from A to B, so you're adding the two vectors now, RA and RAB, that will be basically the same as the vector RB. So now we can rearrange the equation and say RAB is equal to RB minus RA. So a position vector from a starting point to an ending point is equal to the position vector of the ending point minus the position vector of the starting point. So that's kind of, you want to put the definition of a position vector and how the formula for it works. So let's see the other example, which is RBA. So position vector from B to A. So we'll use the same concept, adding vectors here. So RB plus RBA is equal to RA. So this means that I can make a conclusion at the end that RBA is equal to RA minus RB. So you can see here, I'm using the same kind of way of calculating position vector between 2 points, but it matters here, RAB is different than RBA. So that video should be very fundamental to understand position vectors. We learned about position vector of a point, which is a vector representation of its coordinates. And we built on that by learning about unit vector. So it's the position vector divided by its magnitude. And then we generalize here by saying a position vector can be between any 2 points, and it's equal to the difference between the position vectors of the ending point minus the starting point of a vector here in the space. So we'll build on that in the next videos to represent forces as vectors. Unit vector will be very helpful in defining the direction of the force, but the magnitude of the force is not equal to magnitude of the position vector because it's not equal to the distance in space. Magnitude of a force is just a magnitude of a force. It's a Newton or pound. So we're getting basically position vectors to end up with unit vectors that will define directions of forces. So we'll see that in future videos. Thanks for watching. Take care of yourself and those around you.